Good morning, everybody, and welcome to Math with Mr. W. This morning, we have some stuff about the fundamental counting principle. And today we're going to be talking about rolling dice. So here I would really want you folks to have with you pairs of dice. That's all you need. And try and have maybe 20 to 25 pairs of dice in your classroom and just have them on hand, because what I have found in using this particular story, it's really kind of a story, is that it shows to those students that math works, that math is really something that's true in life. And if we can make kids believe that what we are doing is real, that it works, they're going to be much happier about working with it. So here's our story. We've got a set of dice, and kids have rolled sets of dice in games many times. If they've played Monopoly, they've rolled it over and over again, and they're constantly figuring out what the sum total of the dice is so they can move their little piece around the board. Well, this time they're going to do the same thing. They're going to roll a pair of dice. But what they're going to do is they're just going to add up the sum and record what they got when they rolled that pair of dice. And they're going to do it about 30 times a piece. So if you've got 20 kids in your class, that's 600 rolls. So you should be able to get about 600 rolls out of your classroom if you have 20 students. If you have 25 students, you got more. And what we're looking at is two things. We're looking at a theoretical probability, and we're going to look at the experimental probability. The experimental probability is what's happening when your children actually roll the dice. The theoretical probability is what is taking place in theory. That is what they should be getting. So this all falls back on the fundamental counting principle. Remember, with a coin, we have one chance in two times one chance in two. But now we have a set of dice, and each die has 6 numbers on it. So now we're talking about one chance in 6 and one chance in 6. So we've got one chance in 36. So folks, we've got one chance in 36. There's 36 possibilities. Wow, 36. Wow. So I roll a pair of dice. What's the chance that I can make a 2? Well, I don't know which die is which when I roll out there. So I can get a 1 and a 1. That's the only way I can make a 2. A 1 and a 1. So there's only one chance in 36 that I can make a 2. One chance. One chance. Okay? So if I go down here to 12, if I go back down here to 12, it's the same idea. I have 2 6s. So I have to have a 6 on one die and a 6 on the other. There's only one chance in 36 of getting a 12. That's the only way I can do it. So now what about a 3? Now a 3, I could get a 1 on the first die and a 2 on the second die. But I could have gotten a 2 on the first die and the 1 on the second die. Therefore, I have 2 chances in 36. Now, your children should be able to reduce that. That's one chance in 18. So, do I have a better chance of making a 3 than I have making a 2? Yeah. I only have one chance in 36 of making a 2, but I got one chance in 18 of making a 3. Now, let's move forward to a 4. Well, a 4, I've got one chance in 3, or a 3 and a 1. But I also can do it with 2 2s. So there's 3 chances in 36, which equals one chance in 12. It looks like things are getting better for me. And that's right. I got a better chance of getting a 4 than I had of getting a 3. So if I roll the dice 750 times, I should have more 4s than I have 3s. I should have more 3s than I have 2s. Okay? So let's move forward to the 5s. Now, the 5s, I have a 1 and a 4. I have a 4 and a 1. I have a 2 and a 3. And of course, I have a 3 and a 2. So that gives me 4 chances in 36, which equals 1 chance in 9. Wow. I've got 1 chance in 9 of getting a 5. But what are we seeing here? What's happening? Each time we do this, we've reduced the fraction again. So this brings up a whole other thing that I haven't talked to you about yet. And it's something that I've always called the doggy theorem, ARF. Always reduce your fractions. Arf, 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 arf. Oh, I know you're laughing out there. Maybe you're not. But this is called the doggy theorem. Always reduce your fractions. No matter where you are in math, if you have a fraction that can be reduced, reduce it. It'll help you out. It'll make life much easier. So if you can pass this on to your children, help them out. So every time we're doing this, remind them we're reducing fractions. And this is a fundamental thought that you can always do and never hurt yourself. So as I was moving along here, we're doing now up to 6s. What's the chance that I get a 6? Well, I can get a 1 and a 5. Well, I can get a 5 and a 1, and I can get a 2 and a 4, and I can get a 4 and 2, and I get a couple of 3s to make a 6. So I've got 5 chances in 36. 5 chances in 36. So as we can see, each one of these is getting better. Now, when we finally get to 7, we're going to get the best, because we're going to have a 1 and a 6, a 6 and a 1, a 2 and a 5, a 5 and a 2, a 3 and a 4, and a 4 and a 3. So a 7 gets us 6 chances in 36, or 1 chance in 6. Now, here's the neat thing that happens going beyond here. From 8 back to 12, well, look at 12 and look at 2. They're the same. And if you look at 11, you can only make 11 2 ways, a 6 and a 5, or a 5 and a 6. So that's 2 chances in 36, or 1 chance in 18. And if we look closely over here, that's what we have for a 3. It's going to be coming back the same way. So the chance of making an 8 is going to be the same as the 6. We're going to have 5 chances in 36. The 9 is going to be 4 chances in 36, or 1 chance in 9. And the 10 will be 3 chances in 36, or 1 chance in 12. So this is the theoretical probability of getting any one of those. So this is our theoretical numbers. We haven't done the actual values. Now here's where all the beauty comes in. Your students roll those dice 600, 750 times. 900 times, you have 30 students times 30. And you record all of them. And you make sure they count up how many 7s they got, how many 12s they have, how many 2s they have. And you place them on one piece of paper. And you look at how many out of 900 you received. And then you look at how that number out of 900 relates to this theoretical fact. You will be amazed at how close the facts here relate to the ones that your students came up with in their rolling of the dice. It is amazing. In one of my classes, I can still recall, we were using decimals out to the thousandths place when they saw that the 2s they had and the 3s they had were correct to the thousandths place. Correct to the thousandths place. They were going, what? That's not possible. And I said, math works. And many of those students, for the first time, now these are ninth graders, for the first time in their life, truly believed that math works. You folks have third graders. You have them at a time when they're ready to believe. Help them believe now. Don't allow them 6 more years of conspiracy, thinking, does this thing really work? It does work. Math is real. It gives us the right stuff. Enjoy your days at school this year. I'll see you next time on Math with Mr. W.